All right, so we're going to talk about another exponent rule here, and this is what happens whenever you divide and you have exponents there. So again, we see our rule. We have a to the m divided by a to the n is equal to a to the m minus n. So we're going to subtract those two. So you can see here, again, I still added in my coefficients, and so I have 9x to the 7th divided by 3x to the second to the 2 power. Remember, those coefficients still follow the mathematical process, so you're still going to divide the coefficients or whatever symbol you're supposed to do with those, and then this rule, this exponent rule, only applies to the exponent because it's an exponent rule. So then I would take 7 minus 2, and you are going to get 5. So for this exercise, every single time you subtract, you're going to end up with a positive number. However, sometimes that's not always the case. But we'll learn about that later. Again, putting them all together a little bit later on, but just kind of working these out step by step here. So when I have my first example here, I have 12 divided by 12x to the third divided by 6x. So put those all together. So again, you still have bases, and the same bases have to, that's what follows the exponential rules. So those exponents there for the same base follow those rules. Can't start subtracting the x's and the y's variable, or x's and y's exponents together and put them all together, okay? Sometimes we do like a nice, pretty answer, but these are not going to be nice, pretty answers, so just prepare yourself. So I have 12x to the third divided by x to the 6th, 6 to the 6 times x. Goodness gracious. All right, so again, remember, if I don't have an exponent, it's understood to be 1. I'm going to divide the coefficient. So I have 12 divided by 6 times x to the third divided by x to the 1. So I just kind of split it up together, okay? So then I'm going to say 12 divided by 6 is 2, and then I have x, and I'm going to subtract those two. So I have 3 minus 1, which is 2. So 2x squared. That's not so pretty. Don't expect that very much. Let's look at this example here. So we have 64x to the 6y to the 5th divided by 4x to the 4th. So we're going to go ahead and divide 64 divided by 4, not 6, times x to the 6th. You know what? I'm going to move this down here. X to the 6th divided by x to the 4th, and then times y to the 5th, and then there's like nothing down there. There's no y to get together with it, so it just stays up there at the top. So there's not going to be any subtracting there. So again, just kind of showing you some extra example, or just a little different scenario there. So I'm still going to divide the coefficients. So 64 divided by 4 is 16, and then I'm going to subtract the coefficients there. So I have 6 minus 4, which is 2, and then y to the 5th. So that y to the 5th doesn't go away. It's still there. It's still hanging out, okay? And then that's a simplified form. Again, these don't look nearly as pretty as you might want them to. And then this is pretty long, right? So there's 2 rules embedded together. So I have a division, 2 divisions, and then I'm going to multiply them together. So we're going to have to apply these rules. Get used to that. They're going to be stacked on top of each other. So be prepared. So I have 24, a to the 8th, b to the 12th, divided by 3a squared, b to the 4th. I'm going to do that first. Remember, order of operations say do whatever is in the parentheses first. And so I can simplify within the parentheses here. So I'm going to do that first. So I'm going to have 24 divided by 3, and then a to the 8th divided by a to the 2nd, and then b to the 12th divided by b to the 4th. I'm going to do that part first. So I'm going to get 8, a to the 6th, b to the 8th. So remember, I'm subtracting those two together. So this first term there ends up being 8, a to the 6th, b to the 8th. And then the second part here, I'm going to have 16 divided by 2, a to the 18th divided by a to the 9th, and then b to the 10th divided by b to the 5th. And so I'm going to divide my coefficients. So I still have 8, a to the 9th. So I'm going to subtract 18 minus 9 is 9. And then I have b to the 5th. 10 minus 5 is 5. Now I can go back through and multiply those two together. Let's not use an X. I'll use a dot. Okay, so then I'm going to take this and I'm going to have 8. Let's try this again. It's smaller. So I have 8 times 8. Let's those two together, times a to the 6th times a to the 9th. Remember, since I'm multiplying, I'm going to add those two exponents. And then I have b to the 8th times b to the 5th. Again, I'm multiplying, so I'm going to add those two exponents, multiply the coefficients. So I have 64, a to the 15th, b to the 13th. Now, you may be able to just go ahead and not break it all up and then do two separate terms and then multiply it all out together. You may be able to kind of simplify and then multiply, and that will be fine. But if you're kind of struggling with this, it would be a really good idea for you to kind of break it apart, put those together. So remember that this rule is on the formula chart. However, the rule for the coefficient is not on the formula chart because the coefficient for the example on the formula chart is 1. So 1 times 1 is 1, so it's not there. The coefficients still follow the mathematical rule. And then for this lesson, you should divide the coefficient and then subtract the exponents. That's the rule. So divide the coefficients, subtract the exponents. Again, taking these one step at a time, moving forward to putting them all together.